76, okay, with the next hop of 10 6 7 6. And this means that when R7 receives the traffic to the outside for the networks other than the networks inside of this area, it should forward the traffic to the R6, and when the R5 receives this traffic, it should forward to R4. Okay, everything is okay. And let me to show you one problem. Look at here. When R5 receives the traffic to the destination of 172.17.0, for example 1, this is the real traffic, the, for example, HTTP traffic or some other types of traffic. When R5 receives this traffic, it should forward this traffic to the R4, as I mentioned before. And after that, R4 should forward the traffic toward the router 6. Why? You know that between the router 4 and router 6, we have level 1 2 neighborship here. Both of router 4 and router 6 are members of the area, the level 1 area, and also they are residing in the level 2 database also. Why? Because R4 and R6 are level 1 2 routers. Here we have two type of neighborship, L1 neighborship and also L2 neighborship. If you want, you can configure this link as L2 link, and this means that between R4 and R6 we have level 2 reachability. And as you can see, because R4 knows that if it needs to send the traffic to this network, it should forward the traffic to R6, then the traffic from R4 forwarded to R6, and after that R6 can forward traffic to destination. And this is a suboptimal routing. Why? Because R4 can send the traffic to the R7 directly, and after that to the R6, for example. You know, here we have the cost of 100, and this is the, for example, this is not an optimal pass. Here we have the metric of 10 and again 10, but here we have metric of 10 and again, and after that's 100. This means that because we are advertising only default route to the inside of the networks, we have suboptimal routing. Also, assume that R7 receives the traffic to the 172.16.01. Okay, you know that R7 uses the R6 as its default gateway. Because of that, when R7 receives this traffic, it should forward the traffic to R6, and after that R6 should forward the traffic to the router 4, and finally router 4 can forward the traffic to the destination, to the R8. And this is again a suboptimal routing. We didn't use the best pass, we used the worst pass. Here you can see the cost is 100, but here the cost is 10. And this means that we need another mechanism to solve the problem. First, let me to show you this condition, and after that we can talk about the route leaking feature and how we can solve the problem. The first thing that I'm going to show you is the configuration of this scenario. I configured this scenario before in Notepad file. I'm going to show you this configuration. After that, we should apply the configuration, and after that we can understand how we can solve the problem with the route leaking. Okay, let me to show you the Notepad file. This is the Notepad file. We can use this Notepad file for initial configuration for this scenario, starting from the router 4. The router 4's configuration is hostname R4. Then we have three interfaces: Ethernet, Fast Ethernet 00, Fast Ethernet 01, and also Fast Ethernet 10. As you can see here, the Fast Ethernet 00's IP address is 10.454/24. This interface, because this is the interface between router 4 and router 5. And also we have Fast Ethernet 01 with the IP address of 10.464, okay, 10.464/24, and the Fast Ethernet 10's IP address is 10.484/24. Then I enabled router ISIS with the net address 49.0.0.0.1. This is the area ID for the router 4, and this is the unique system ID. After that, ncell. Also, I enabled logging for adjacency. And after that, interface Fast Ethernet 00, this interface IP router ISIS, and then ISIS circuit type level 1, because you know that R4 is one of the level 1 2 routers. And also for interface Fast Ethernet 01, I configured IP router ISIS and also ISIS circuit type level 1. because in this scenario we need to configuring cost of ISIs for this interface, here we can use the for example ISIS command with the metric keyword for configuring the ISIS metric on this interface. Look at here. You know that in the previous video you learned that if you want to configuring for one interface metric, you can use ISIS metric command on this interface with the value. I talked about this feature in the metric scenario. Here I'm going to use ISIS metric 100. You know that by default ISIS uses the metric number of 10 for every routers. And after that, here on interface fast Ethernet 10, we have IP router ISIS, and this is the level 2 interface. This is the initial configuration of router 4. Let me to copy this configuration and pasting on the router 4. If we find some errors, we should first troubleshooting that errors. In the router 4 CLI, without any configuration, we can copy these commands. Look at here. Here you can see the metric style white error. Why? We configured ISIS metric 100 and this is greater than 63. We need the metric style wide. As you know, it's in best practice we should configure the metric style wide in all routers. Metric style wide. That's it. And after that, here now we have no problem. Again, we can copy the all of configuration, or if you want, you can use only the part of ISIS for configuration. Let me to copy all of the configuration and paste it here in the router 4. As you can see, we don't have any error message, and in the show run interface fast Ethernet 01, you have the ISIS metric 100 command. Very good. Let's go to the router 5. This is the second router. In second router, the host name is R5, and this is the L1 router. Interface fast Ethernet 00 with the IP address of 10455/24, and then the interface fast Ethernet 01 interface with the IP address of 10575/24, and after that router ISIS. This is the area ID, this is the unique system ID, and this is the NCell. IS type is configured to level 1, and log adjacency change now is enabled. Also, we enabled ISIS on both interface of fast Ethernet 00 and fast Ethernet 01. That's it. This is the configuration of router 5. Let me to copy this configuration and pasting on the router 5. Look at here. We don't have any error. And after that, let me to configure first router 6. In router 6, we have the similar configuration with the router 4. Host name is router 6, and the IP address of fast Ethernet 00 is 10676/24. The IP address of fast Ethernet 01 is 10466/24, and the IP address of the fast Ethernet 10 is 10696/24. Then router ISIS command. This is the area ID, this is the unique system ID, and this is the NCell, and we enabled logging. Interface fast Ethernet 00 and fast Ethernet 01 are configured with the IP router ISIS command, and then ISIS circuit type level 1. And finally, for fast Ethernet 10, we configured IP router ISIS with the ISIS circuit type level 2. That's it. Also, you know that we should configure the cost of 100 here on the fast Ethernet 01. First, we need to configure metric style wide in the router 6. For example, on the interface fast Ethernet 01, now we can configure ISIS, okay, metric, then 100. And also, you know that when we are configuring metric style wide, it's necessary to configuring this command on all routers. Because of that, let me to also using this command on the router 5. Here on the router ISIS, and also on the configuration of router 7. This is the router 7's configuration. And after that, for example, router 8 and router 9. You should configure this command on all routers, and you know that this is the best practice. I configured this on all routers. As you know, in the router 4 we configured it before, but in the router 5, when I copied the configuration, this command didn't exist. Because of that, let me to copy the configuration of R5 again and pasting on the R5 CLI. This is the R5 CLI, and that's it. After that, in router 6, we can copy the configuration. We checked it, and here this is the configuration of router 6. Copy. And after that, we can paste on the router 6 CLI. This is the router 6 CLI. We don't have any